Touch the lake. Good evening, everyone, and good morning and good afternoon to the speakers and all the viewers joining us from Tibet House Facebook Live and Tibet House YouTube Live from different parts of the world in different time zone. I'm Stanzan Ladol, the convener of today's program organized by Tibet House, Culture Center of His Holiness the Dalai Lama, New Delhi. First of all, I would like to welcome you all to today's very important dialogue between quantum physics and Arya Nagarjuna's philosophy of emptiness. Today, we have two very prominent speakers, a renowned scientist, Professor Nicholas Gisson, to speak on quantum physics, and an eminent Buddhist philosopher and psychologist, Venerable Geshe-Dorje Damdula, representing Arya Nagarjuna's philosophy of emptiness. I would like to welcome the chairperson for today's event, a very senior physicist, Professor Sissy Roy, and National Institute of Advanced Studies, Bangalore. Likewise, let us all welcome Professor Nicholas Gisson, a physicist and professor at University of Geneva, Switzerland, and Venerable Geshe-Dorje Damdula, Director of Tibet House, Culture Center of His Holiness the Dalai Lama, New Delhi. Before we proceed, I would like to give a brief overview of Tibet House. Tibet House, Culture Center of His Holiness the Dalai Lama, was founded in 1965 by His Holiness the Dalai Lama to preserve and disseminate the unique cultural heritage of Tibet and provide a center for Tibetan and studies. Tibet House also has a museum of valuable Tibetan arts and artifacts as well as a library. Tibet House regularly organizes lectures, national and international conferences, exhibitions, film screening, and festivals throughout the year. These programs mainly focus on Indian, Tibetan, and Nalanda Buddhist history, science, religion, philosophy, art, literature, and culture, where it witnesses the vital and evolving heritage of the Tibetan people. Tibet House also offers different courses on Buddhist philosophy. At present, a 5-year Nalanda Master course in which 360 participants are enrolled from 39 countries, and 1-year third batch of diploma course on Buddhist philosophy in which 860 participants are enrolled from 41 different countries and has been completed with 2 batches. We also offer a Tibetan language course every 4 months, and till now, 21 batches have graduated so far. Now, I would like to request Mr. Tenzin Chokdanla, Secretary Tibet House, to kindly present the welcome address. Mr. Tenzin Chokdanla.
Good evening, everyone. Good evening. On behalf of Tibet House, Culture Center of His Holiness the Dalai Lama, New Delhi, it gives me immense pleasure to extend a warm welcome to our distinguished chairperson, Professor Sissy Roy, our eminent speaker, Professor Nicholas Gisson, and Venerable Geshe-Dorje Damdula, and all the participants here tonight. It is gratifying to know that the conference covers a wide variety and very interesting topics such as non-locality, entanglement, interconnectedness and dependent origination, Nagarjuna, quantum correlation and reality of relations in Buddhist philosophy, role of thought experiment in quantum theory and in Buddhism, concept of time in quantum theory and time in Mulamadhaymika Karika, and so forth. In the Heart Sutra, it says, form is empty, emptiness is form. Emptiness is not other than form. Form is also not other than emptiness. This has been most commonly related to Noethel's quantum theory, which asserts that matter and space are not different. Keeping this at our own surprise to explore more, it is an opportune time to renew our thoughts and discuss in depth the mutual interest between the two most talked about topics of all times, the science and the Buddhist philosophy. We are all deeply honored to have with us here today our chairperson, Professor Sissy Roy, National Institute of Advanced Studies, Bangalore, and our eminent speaker, Professor Nicholas Gisson, physicist and professor at the University of Geneva, and Venerable Geshe-Dorje Damdula, Director, Tibet House, New Delhi, who will elaborate more on the correlation between the quantum physics and Arya Nagarjuna's philosophy of emptiness. I hope this dialogue will be of great benefit to all the participants. So without much delay, I would request Ms. Chandan Narula to proceed with the session. Thank you.
Thank you, Mr. Tenzin Chokdanla. We would like to introduce today's chairperson, Professor Sissy Roy ji, for the event. Before I do so, this is to bring to the attention of the audience that we have question and answer session at the end of the dialogue. I request you all to send us your questions through the live chat of Facebook and YouTube, the selected questions will be shown on the screen for the chairperson to invite responses from the speaker. Now, we would like to introduce today's chairperson, Professor Ciceroiji.
For today's dialogue between quantum physics and Arya Nagarjuna's philosophy of emptiness, we are delighted to have Professor Shishir Roy as the chairperson. Professor Roy from National Institute of Advanced Studies, Indian Institute of Science, Bangalore, is a theoretical physicist working on foundations of quantum theory, cosmology, and brain function modeling. He has deep interest in Indian philosophy and epistemological issues in modern science. Professor Roy has published more than 200 peer-reviewed papers in various international journals and 15 research monographs and edited volumes with publishers such as Kluwer Academic Publishers, World Scientific, Springer, Routledge, Taylor and Francis, etc. His recent monographs include Demystifying Akasha, Quantum Vacuum and Consciousness, jointly produced with Ralph Abraham, published with Epigraph in 2011. Decision Making and Modeling in Cognitive Science, published with Springer in 2016, and Understanding Space-Time and Causality, Modern Physics and Ancient Indian Traditions, jointly produced with B.V. Srikantan, published with Routledge, Taylor and Francis in 2020. Professor Roy has also visited many US and European universities as distinguished professor.
Now, I would like to request Professor Ciceroiji to kindly say a few words on today's event.
Good evening, speaking from Bangalore. It's a privilege for me to give some introductory address to such a big event. In fact, the dialogue is an Indian tradition. Many centuries before, in Nalanda, we have these traditions. And His Holiness Dalai Lama, he tried to introduce this kind of dialogue, bringing the eminent scientists from various parts of the world. So I think the Tibet House, his cultural center, is doing a very marvelous things to promote this kind of dialogue which is necessary. And the problem with this kind of dialogue is the following. We, the physicists, we have a different language. And the philosophers, including Buddhist one, they have a different language. So problem is how to communicate. So what we are trying to do here, we have identified some of the issues which raise a lot of epistemological issues since the birth of quantum theory in 20th century. And these epistemological issues were discussed by Indian philosophers from various schools, including Buddhist ones, many, many centuries before. Now the question is how it is relevant in modern context. Yes, it is relevant in the sense that our sages or scholars from different schools of philosophy, like Buddhist philosophy and non-Buddhist philosophy, their wisdom can give a new insight to resolve or to understand in a more comprehensive way the issues raised in quantum theory. So, some of the issues you have seen that non-locality, then quantum correlations, quantum reality, this kind of issues we have chosen. But the problem is that how a physicist like Professor Nicholas Gishin and Geshe-la Dorji Damdullah, they will interact because in case of, I'm giving one example, like non-locality. So non-locality is nothing but a kind of influence of one entity one microscopic entity like electrons, proton, or photon to another microscopic entity like similar entity, electrons, photons, or protons. They are separated far away distance, but in certain conditions, they give rise to some influence to each other. And apparently, there is no physical connections between these two entities. Now, if they have influence, means they have some kind of connectivity or connectedness, then the question is whether they have the property or attributes. In Sanskrit we call swabhava, or in Tibetan ramjam, or in English intrinsic or inherent property, like the charge of electron, spin of the electrons. So according to Nagarjuna's doctrine of pratitya samutpada or dependent originations, if one entity is correlated or interconnected to other entity in the universe, then they should not have intrinsic property. Now my question is to Nicholas Gisin, that in standard textbook of quantum theory, we say that elementary entities like electrons, protons, etc., they have intrinsic property. And now, if they have intrinsic property, then how it will be compatible with pratitya samutpada or dependent origination to my friend Geshe Dorji Damdullah. So that way we can start the dialogue, and I will try to say something for other issues, maybe when the dialogue will start one after another issues. Thank you.
Thank you. Thank you, Professor Siseroiji. Now, we would like to introduce our today's two prominent speakers, Professor Nicholas Gisin and Venerable Geshe Dorji Damdullah.
Professor Nicholas Gisin is one of our prominent speakers for today's dialogue between quantum physics and Arya Nagarjuna's philosophy of emptiness. Professor Gisin is currently a physicist and professor at University of Geneva, Switzerland. His PhD dissertation was on quantum and statistical physics. In 1988, Professor Gisin joined the group Applied Physics at the University of Geneva as head of the optics section. Under his leadership, two new research directions, one in optical sensors and another in quantum optics, were launched. And some of his research also led to many patents and technological transfers to Swiss and international industries. More recently, his work on demonstration of quantum cryptography and long-distance quantum entanglement received incredible attention both from the international scientific community and from the press. In 2009, he was awarded the first biennial John Stuart Bell Prize for research on fundamental issues in quantum mechanics and their applications. He was also awarded the Swiss Science Prize in 2014 by the Foundation Marcel Benoit, the highest Swiss prize for all sciences. He has also received several awards such as Quantum Communication, Measurement and Computing Award in 2014, Volta Medal from the University of Pavia, Italy 2015. He was honored award, an honor given to scientists every 4 years by the city of Geneva. Professor Gisin has authored several books and articles such as Quantum Chance, which has been translated from French into English, German, Chinese, Korean and Russian. With this introduction, I now welcome Professor Nicholas Gisin. Venerable Geshe Dorji Damdul is the director of Tibet House, Cultural Center of His Holiness the Dalai Lama, New Delhi since 2011. Venerable Geshe Dorji Damdul holds a Geshe Larampa degree from Drepung Losling Monastery and has served as the interpreter and translator for His Holiness the Dalai Lama within India and abroad for several years. He is the chief editor for several compilations and has co-authored numerous Buddhist and secular books such as Ethics for the New Millennium Part 2 that was later entitled Beyond Religion. He has also collaborated for research with prominent professors in the UK and USA, including Professor Paul Ekman. Venerable Geshe Dorji Damdul has translated several important Buddhist philosophy texts, including Arya Nagarjuna's Mulamadhaymika Karika. He has written papers for national and international conferences held in Delhi University on varied topics such as the paradox of brain and mind, and the other being ultimate reality according to Arya Nagarjuna, which are also in the process of being turned into books. Venerable Geshe Dorji Damdul was also designated as the philosophy lecturer for the Emory University Study Abroad program being held in Dharamshala, India since 2001. He was appointed as visiting fellow to give lectures in the departments of Buddhist studies, philosophy and psychology in Delhi University, and was also empaneled as one of the chief experts by IGNOU to design the BA and MA course syllabi on Tibetan studies. He is also a renowned teacher of Buddhist philosophy, single-handedly anchoring the Nalanda Master's course and numerous batches of the Nalanda Diploma course of Tibet House, New Delhi, with up to 2,000 and more students from more than 50 countries, as well as holding regular teachings across the globe. His unique ability to converge ideas from Buddhist philosophy with physics has drawn towards him varied audiences across the world. I now invite Venerable Geshe Dorji Damdul to take the stage.
Welcome, our chairperson and all the speakers, our two speakers. Now I would like to give the stage to our chairperson, Professor Ciceroji. The stage is yours.
Thank you. We are now welcome Professor Nicholas Gishin and Geshe Dorji Damdullah. Let us start with the dialogue. And the first topic is non-locality and interconnectedness in Nagarjuna philosophy. Let me again stress the point that the main issue in Nagarjuna concept of emptiness, as I understand, that every object in the universe is connected with other one, and they are devoid of svabhava or intrinsic property. Now I will ask Professor Nicholas Kishin to talk about the non-locality, emphasizing the importance of inherent or intrinsic property like charge, spin, etc., or whether we need it or we don't need it in this context. And the protocol is 5 minutes to each of the speakers because we have several issues and always, like usual, we have time limit. So, Professor Nicholas.
Okay, so thank you very much. I'm very glad to be part of this dialogue. Let's see how far we can go. So let's start with non-locality, which is clearly one of the most fascinating topics in physics, especially in quantum physics, which is really my specialty. And so what does it mean? So let's take two particles. And these two particles, it could be more than two, but you need, let's say, two. And we separate them in space. So we have two particles that can be really at a large distance. So experiments go to kilometers and kilometers, but in principle, the theory says it could be even further away. Now, a particle has several characteristics. It can have some mass or some charge, as you just mentioned before. And then it can also have some different properties like this spin. It is like a little vector is pointing in some direction. But it could also just be the position of the particle. It could be a bit to the left, or a bit to the right. And indeed, when you have this non-local phenomenon occurring, it means that some of the properties of these particles are just not determined. For instance, the particle could be at the same time a bit on the left and a bit on the right. And this, let's say, for a classical physicist doesn't mean anything. Either it is, my bicycle is either a bit here or a bit there, but it cannot be here and there. But for these quantum particles, whether it's electron, protons, or photons, which are light particle of light, that can happen. And then since we have two particles, both particles could have some of their properties undetermined. And what is now really the most surprising and the most interesting is that if now I perform a measurement on one of these particles, I force it to make up its mind, or I force a property of this particle to get determined, to get a fixed value. For instance, it's definitively on the left or it's definitively on the right-hand side. The other particle, which actually can be kilometers away, really a long distance away, it could even be in a position, in a place that the first particle has no idea about. Nevertheless, the second particle will also acquire a definite or a determined property, corresponding property. And so this is, okay, non-locality, and we can make experiments and show that this is really like that. And I don't know how much you want me to go into that, because it gets a bit complicated and technical. But indeed, you have this idea that this property beforehand has no structure. Maybe you say it's emptiness, I'm not sure about that, but for sure it has no structure. It is fully random, fully undetermined. But once I do a measurement, I get a result. So that this property that I have measured has now a very well determined value. And the other particle, which may be again kilometers away, simultaneously acquires the corresponding value of the same property. And so indeed we go from, let's say, a lack of structure, an absence of structure, to a well-determined structure. So it is not that nothing is determined initially. For instance, I have a particle, let's say these are photons, let's say just photons. It doesn't matter, you can think of whatever you want. But let me take the example of photons. So photon bears some energy. So the energy is there. It's maybe not fully determined, but there is some energy there, and there is also some energy of the other particle at the other side. But maybe the position, the exact position, or maybe just the spin of this electron is initially totally unstructured. So it's not really a vector. It's going in all directions, or it has no direction at all. It has no structure. But afterwards, after the measurement, of course, the particle that I have measured has now a well-defined spin. So it's okay, for a photon, it means the electric field oscillates in a well-defined way, well-determined way. But the surprising and really the nice thing about quantum physics is that the other particle also, although I didn't touch it, I did not touch that one, but nevertheless, it now has acquired also a well-determined polarization, as we say, or spin for photons. So it's not that nothing goes into something, but some property go from totally unstructured to well-determined.
Okay.
Is that confusing enough?
Okay. Let us listen to what our Buddhist friend, he talks about interconnectedness and Nagarjuna philosophy.
Thank you so much, Chairperson Dr. Ciciroji. So basically, as for the understanding this concept, what is presented in quantum physics, the non-locality, entanglement, there, in Buddhist philosophy, first, what we need to know is that the objectivity versus the subjectivity, and where things are seen as objectively real, then all these, what is functionally observed and what is conventionally observed in reality, they cannot be posited as as feasible, or they cannot be seen as tenable. So with this in mind, all these, the primary Buddhist philosophy schools they have their own positions of what the ontological reality is, and then on that basis, they try to present their philosophy. And whereas the highest Buddhist school, so it is in a way, it's very interesting that the say beginning with the first school, which is Vaibhashika, from there, as you climb the steps to go to the highest one, which is Prasangika, there degrees of objectivity are being rejected. Then finally, when you reach the Prasangika, all degrees of objectivity are rejected. Then we come to realize that from the object, there's nothing there to be seen as the distinct. And then it's all but a part of this subject. Yet it doesn't, yet it's very important that the two things to keep in mind. One, with the subjectivity, where there's no objectivity at all, with the subjectivity, still things function. And with the subjectivity, all phenomena, they can be accounted for very easily, particularly in the context of the Newtonian physics, like the law of the actions and the law of the motion, and all these things can be posited, and also the functional world, which otherwise there are so many debates happening how you account for this phenomenon, that phenomenon, and so forth. Now, with the advent of quantum mechanics, the non-locality, entanglement, all these concepts came into being. So the point is that basically Buddhist philosophy does not really go to tackle this particular one phenomena known as non-locality per se, but the question is that with this subjectivity, where the rejection of all objectivity and positing things infallibly well on the basis of subjectivity, there, then when the functionalities are seen to operate so well, then is there possibility for one to explain the non-locality, entanglement, and so forth? First of all, for this, I like to give my two quick opinions. One is pertaining to a question, and the other one is how we can possibly see the compatibility between the two. The question is the measuring the two electrons separated by distance, like 1 kilometer or 10 kilometers, whatever. So there, when you see the property of the electron, then it is said that the second one is automatically determined. So the question is, in terms of time of the measurement. So to know the second property of the second, to say that the property of the second one can be determined on the basis of what you see of the first one. So how do you measure? So measurement must be done in time. So are the two done at the same time, or there's a lapse of 1 millisecond or 1 trillionth of a second? So this is a question. And then I oftentimes, when I discuss with the quantum physicists, I come to learn that they speak about one particular time. So this is something which we need to consider. We think of the be it quantum physicists or the philosophers, that one time. What do you mean by one time? We talk about, say, the 12 of the PM sharp, 12 a.m. sharp. Where is this 12 a.m. sharp? Is it time or not? If it is time, as going to be discussed later on, time should have at least three components, beginning, middle, and end. If it has three components, how can you be so precise to say that this is the at this particular time, same time? How do you fix that? This is one question. And then the number two is that so now whether or not there is compatibility. So in terms of the classical text, or you say any description of locality, non-locality, or the entanglement and so forth. In Buddhism, yes, when you speak about dependent origination, since the objectivity is all rejected, then subjectivity with the subject, your mind, how the mind behaves. So what the outside object they behave, how it behaves, is just a reflection of how the mind behaves. Because objectivity is rejected and subjectivity is explained. So with this in mind, with the subjectivity, we say in the text, we do find the mention of the qualities of the enlightened beings, the realized beings, where say the individual person here manifests the different forms, and then the emanations, they behave, they are separated by distance, not separated by time. They are separated by physically, they are separated by distance, and yet say how they behave, they all can behave simultaneously in the same way. So these are the say, of course, this is what we find mentioned in the text. At the same time, how do we explain this on the empirical, say, cause-effect relationship and so forth, and on the basis of the explanation of the subjectivity. So this is a very serious point. In other words, where the subjectivity is the explained, then it Arya Nagarjuna, the second century great teacher, he said that where the subjectivity is explained, then the functionality can be explained infallibly well. Where the subjectivity cannot be explained, if you posit objectivity, then the functionality cannot be accounted for. Thank you.
Thank you. Let us go to the next questions, because maybe
Maybe should I? Sorry, Sisia. I think that Dr. Abdul asked some very good questions, and maybe I should just try to elaborate.
okay,
Is that
okay,
possible?
yes, go ahead.
Because I think so. My understanding there was these two questions about objectivity and about time, and especially about time. I think this is very relevant also in physics, and indeed in physics. So in the experiments about non-locality, we pay a lot of attention to do the measurements on both sides. So one measurement that triggers this determination, but we do a measurement on the other side, and then we try to make it as much as possible at the same time. And we are very precise, much better than milliseconds. It easily goes to, let's say, nanoseconds. So a billionth of a second. So it's super precise. But still, time is a super delicate concept in physics, and I don't think we, the physicists, understand time very well. And we also have then to talk or to mention relativity. According to relativity, even to know which one is the first depends on the reference frame. And one experiment which I like maybe to mention here is an experiment in which the two particles, the two sides, including the measurement instruments, were moving apart from each other quite fast, but like a fast car. So not super fast, but fast enough such that from one particle point of view, this inertial reference frame, this particle was doing the measurement first. So it could not be influenced by the other. But seen from the other particle, in his own inertial reference frame, this particle was doing the measurement first. So both are doing the measurement first, seen from their own inertial reference frame or their own point of view. And since they both do the measurement before, so we call that before configuration, you see there's no one that can influence the other since both are doing the measurement before the other. And I think this experiment underlines nicely what we just heard about the difficulty of bringing together this concept of quantum non-locality, entanglement, and the concept of time. And I'm sure that time is simply not well understood by physicists today. So that's what I wanted to say quickly on objectivity. I have probably less to say, but on time, I think this is super important, and it was a very, very well taken point by Dorji Damdul. Thank you.
Thank you, Nicholas. Okay, let us go to the next issue. It is called quantum correlation and reality of relation. So, what do you mean by that? Most physicists, we know that when you say non-locality or entanglement, there is a correlations, or simply there is a relations between the two entities or two objects. Now we say the two objects called relata or relatum, and the relation which binds the two entanglement. This is called relations. So the issue is the Buddhist philosopher and logician Dharmakirti, 8th century, I think, he wrote a big book called Sambandha Pariksha, or Examination of the Relations, where he claimed that relation, in ultimate analysis, relation is not real as relator. But we know in quantum teleportation experiment that entanglement or this relation is real because it is performed in the labs. So if you first say what is exactly quantum correlation in quantum perspective, and then I will ask Geshe Torjid Abdullah about the Buddhist point of view.
Okay. Thank you very much. Yeah, indeed, there are a lot of debates among the physicists with my colleagues, and indeed some of my colleagues they say, okay, yeah, these quantum correlations show some non-realism. It's against realism, and what they mean, if you study a bit, they mean that it cannot, the result of this measurement cannot be predetermined. It's really that the property we are measuring was initially not determined, and it's the measurement that brings about the determination of the value of that property. So this is, in my opinion, not a matter of realism or anti-realism or whatever. It is like that. That's the way the world functions, and indeed the world so is indeterministic. Now, indeed, as you said, Cecilia, there are these correlations. And here we're talking about two of them in teleportation, as you mentioned, and there are three of them. And you could have, in principle, it's not limited. Of course, for technical reasons, we cannot really do it with tens and tens. But in principle, you could have really these entanglement and non-locality among many particles. But let's stick to two because that's the interesting case. And indeed, so you have these correlations that come about, and there's some kind of non-local randomness that comes about. And I would really like to emphasize that this is really real in the sense that you can do the experiment in a very reproductive way. Reproductive, not case by case, but the statistics. The statistics is always the same, and it's the statistics that corresponds to the probabilities predicted by the theory. And we know how to compute these probabilities very well. It functions very well. But so since it is always possible to reproduce that, and both in Geneva, in India, in the US, in China, and many places, my friend Anton Zeilinger would do it in Vienna, and so on. And so everywhere you can do that. And it's again, the statistics is very reproducible. The phenomenon of non-locality is absolutely reproducible. So I don't really see why we should, mention that this is not real. If something really happens all the time, again and again, I would, on the contrary, see this is very real. I can really work on it. I can put a student working on it. It's going to be reproducible. You can develop ideas. You can develop applications, technologies around that. So for me, these quantum correlations are absolutely real, let's say my cup of tea here with my little hockey player. It's absolutely real as I see it. Thank you.
Okay, thank you. Now, our friend, Geshe Torjid Abdullah, what?
Okay. Thank you so much. The concept of relation from the Buddhist philosophy point of view, in the first place, what I'd like to share with the audience is that when we reject the objectivity, any degree of objectivity, it doesn't mean that nothing exists. This is so important because this is known as the infallible operation of the functional world, and it is for this reason that these four schools, Vaibhashika, then the Sautrantika, Chittamatra, Madhyamika, these four schools, how they are presented one of the other is in ways of the individual maturing in the understanding of this concept of emptiness. Say, when you speak about the rejection of the reality, it doesn't mean that nothing is real. It's just all imagination. If this is the connotation somebody gets, and then one falls into the trap of what we call as the nihilism. So the real understanding of emptiness is that where, for example, let's say I should be able to posit for example, COVID-19. It is real. When we cannot deny the existence of COVID-19, and still, while you very strongly adhere to the existence of the COVID-19, which is very destructive, with the outbreak of it all over the world, and at the same time, you see that still this is without contradiction happening in the ambience of the emptiness of objectivity. In other words, say on the one side is the emptiness of objectivity, and on the other side is the infallible reality. Infallible reality meaning the reality of the functionality. Precisely, things exist there. This is a flower. This is a dialogue happening. And the time duration, the time taken for the cesium to disintegrate, it's this, like they say, the millionth of a second, and so forth. These positions, if one rejects these realities, one falls into nihilism. So that should not be, these are not to be rejected. In other words, the point is that we talk about the two realities. One is the ultimate reality, and the other one is the conventional reality. So the reality that we are talking about, say, two things exist. Physics exists in the past, like 300 years ago with Newtonian physics. Now quantum physics, relativity theory, and stuff, do they exist? Yes. Is there a transition? Yes. There's a paradigm shift? Yes. So these are all realities. Nobody can deny these realities. At the same time, that all these realities are happening on the subjective level. So with this in mind, it's a very interesting discussion where, say, the Acharya Dharmakirti, as presented by Professor Sisiroj in his text, a very classical text on logic, presents how the relation is explained. And say from his point of view, say there are two things. One is the infallible, say the functional things, like say the atoms, electrons, protons, neutrons, so forth, and how they're related. If you go 100% on the object, for example, like say when I move my hand, all these atoms, they move in a sync. So how are they related? And we see that there is a hand there. Yes, there's a hand there. This is an undeniable fact. So with this hand in actuality is nothing but made of billions of trillions of atoms. And these atoms, how they behave in sync. So they behave in sync that we project a hand over this. We project a hand. So now the point is that Acharya Dharmakirti, he was from the 7th century AD. What he said was that while the his contemporary non-Buddhist philosophers and logicians, they came up with the idea that relation is something undeniable reality, relation. Just as the hand is undeniable reality, the relation, even the phenomenal relation, is also undeniable reality. What is undeniable reality? Must be substantially real. So whereas Acharya Dharmakirti says that, no, the moment you project this substantial reality of the relationship, then you cannot account for all these debates. So many debates are thrown by him to reject. In fact, I have the PowerPoint presentation prepared, but this is done in such a way that it would take a lot of time if I to make it short. Acharya Dharmakirti said that substantially there's nothing to identify as, okay, this is what is known as relation. No, they are the basic substance substrata, or what Professor Cicero calls as the relata, or the substrate, the substrata. There are substrata there, and these substrata. So the manner in which I explained now, all these billions of atoms there, and from with our naked eyes, we see as a hand. We see it as hand. So this is just what our mind projects. And from the object, if you go close to the object with the electron microscope, you just see billions of atoms. That's it. There's no hand there to be seen. So, and alongside, on top of there's no hand to be seen, there's no relation also to be seen as substantial reality. So it's only through, say, with the subjective, the observation, that the hand is perceived, and then there is something which our mind projects, something which pervades all these billions of atoms as a unison. So that is purely comes from your projectional mind and not really from the object. So the relation is a phenomena which does exist, but existing by a part of the mind and not from the substance. But it's a substrata, atoms, so forth, from the point of view of Acharya Dharmakirti, not from the point of view of Arya Nagarjuna. From Acharya Dharmakirti's point of view, he made the distinction that things exist. Some of them exist as substrata, and some of them exist as purely come from the mind or by the thought. In other words, observer. The observer is there, and the observer's the role to bring about the phenomena. And that phenomenon, the performing or functioning infallibly well without any contradiction. It is not imagination. So we need to make a distinction between imagination and the intuition by the mind. So the relation is explained on the basis of the non-substantial phenomena, which comes into existence by the projection of your mind.
Thank you. Let me ask one thing. In Buddhist philosophy, also in other non-Buddhist philosophy, they use the term conventional reality and ultimate reality. But we physicists, it's very difficult for us to distinguish what is ultimate reality and what is conventional reality. So, Nicholas, would you
Okay.
like to comment?
Well, I guess for a physicist, we are interested in ultimate reality. That's really our goal. Now, of course, do we really achieve that goal? There was a time when Newton's physics and Newton's mechanics was considered as describing this ultimate reality. Today, it is more like quantum physics and relativity. Most likely in some time, I don't know, some decades, it will be yet another theory, quantum gravity, or I don't know exactly what. But still, so I don't think we are really achieving the dream of describing ultimate reality. But there is no doubt that the goal and the dream of a physicist and the motivation of physicists is to get closer to this ultimate reality. Physicists never really talk about conventional reality. What we may say is that we have a theory which is a good approximation of this ultimate reality. Maybe this could be called conventional reality. It's the convention according to that theory, but that's not a terminology that physicists would use.
Yeah, Geshe-la, would you like to comment very briefly?
Thank you so much. In fact, I remember during a conference when Professor Mugundu was still alive, and he was the chairperson, and I was talking about the ultimate reality. And Professor Mugundu, who was a scientist, a physicist himself, and Professor Sisirji, his name is Professor Mugundu, who passed away.
No, he didn't pass. Professor Sikandan passed away.
Sikandan, yes. Yes, Professor Sikandan, and he was the chairperson for that session, and he was very unhappy. He said that first, how do you know that the what you present as ultimate reality is actually the ultimate reality? How do you know that? How do you establish it? This is very interesting. And he said that in the physics, we don't talk about ultimate. How do you know that this is ultimate? This is a very serious question. Okay, before I go too much into what is this ultimate and so forth, what I'd like to share with you is that the physics, one challenge is the how to unify these two, the relativity theory and quantum mechanics. Quantum mechanics, which explains mainly about the macro world, and the relativity theory, which explains mainly about the macro world. So now what I would share with you is that what as Professor Cicero is talking about, the two truths, conventional truth and the ultimate truth, is that the parallel to this, relativity theory explaining the macro world and quantum physics explaining the macro world in the domain of the physics. Parallel to that in Buddhism, these two truths, parallel doesn't mean that these two are identical. In Buddhism, we speak about things existing only with your mind as a frame of reference. In the absence of mind, things make no sense. Only with your mind as a frame of reference, things exist. So your mind, there are two kinds. The mind which views the object from distance. That is, you see the things in the macro. For example, if I look at the Milky Way galaxy from planet Earth, I can see the Milky Way, part of the Milky Way galaxy. But if I'm deep in there, or say if I'm deep inside the bunch of the atoms, I don't see the flower, I don't see the person. From distance, I can see the flower, I can see the person. So what I see from distance with respect to the object, that mind as a frame of reference, then that object, whatever the object is perceived to be functioning as, that is known as the conventional truth, a truth seen by a conventional mind. Now we speak about, let's say that the electrons, proton. First, let's say the piece of bread we all have to eat. This is a reality, one reality. But when it comes to the point, where did you place your bread? Where do you place the bread? I could not find it. Right? Oh, in the refrigerator, not outside. It's localized. This is reality. We cannot deny this reality. At the same time, so that reality, which conventionally is understood, is known as conventional truth. And where you go deeper into this, on the level of the electrons, then where is it? This one, that one. So you see the entanglement there, you see the non-localized there. So this is this is also not to be denied. This is also to be seen. So that behavior, which is very different from how the same object behaves on a macro level, this contradiction, what is seen on the macro level is known as conventional truth. What is seen in the micro level is known as the ultimate truth. The next question is, what is seen on the micro level? Macro level, it doesn't mean just going into the atoms or the electrons and so forth. This is not the ultimate understanding of the macro level from the Buddhist point of view, but it is very close to that. As you go closer on the atomic level, the function of the world simply collapses. In other words, the relativity theory, macrocosm simply collapses when you go on the quantum mechanics level, quantum level. So with this in mind, what is seen very closely to the object, that is that reality as seen with the frame of reference, with this mind which goes too close to the object as a frame of reference, whatever is seen by that mind, validly what is seen by that mind is known as ultimate truth. So next question is, what is that? What is that? This is a huge question. What do you find there? What do you find there? Sometimes I hear from Professor Cicero about the quantum probabilities, or what do you call it? The quantum vacuum. Quantum vacuum. So, Professor Cicero would say that this quantum vacuum there is described as vacuum. Likewise, I say in Buddhist philosophy, what is seen as emptiness, the same object which is seen as emptiness by the ultimate analysis, the mind, the ultimate analysis is a frame of reference. The same thing is seen as the flowers, like Professor Gissen or Professor Cicero, the house, and so forth, with the conventional analysis at the frame of reference. So the same object displays two different qualities with respect to depending on the two different frames of the mind.
Nicholas, would you like to make any brief comment on this?
Yeah, well, thank you very much. I think it was pretty clear, and I think it's not so far from the physicist. And so we aim at this ultimate reality, but of course we never really get there. And the best the physicist can do is to have a model or a theory which is getting hopefully closer. And indeed, when we go to the atoms, we have really the feeling we get closer to this ultimate reality, but we never achieve it. We never really touch it. And so maybe one could indeed say that our theories are just conventional reality, to use this terminology. We would just say it's a theory of the atom or a theory of the micro world and so on.
Okay.
One sentence, if I may be allowed, is that say, what is my take of the physicists or the current physics pertaining to the understanding of the relativity, or the understanding of the ultimate reality and conventional reality, is that I would say that physics and the two physicists here, you can elaborate on this later. I'll say that the physics, with quantum physics, we come to realize that, for example, that the localized concept dissolves when you go into the non-localized state. And then likewise, the randomness also, say the function, the cause-effect determinism, the cause-effect relationship, the reality that exists in the conventional world, that also dissolves in the face of the quantum randomness. So these things, what is happening is that the quantum physicists, they go into this to explore the deeper and deeper and deeper reality, and then they don't question what is that thing which we infallibly saw, which infallibly operates, like, let's say, the cause and effect efficacy, number one. Then the localized nature of the world. As I said earlier, okay, where's the key? I lost the key. Where's the key? So I've misplaced the key. So these are all undeniable facts. When you go to the quantum level, how would you describe these phenomena? Would you say that they exist or they don't exist? Or how do you explain this and compatibly with the quantum phenomena? So now, if you are in a position to look for the reconciliation or look for the compatibility of the two things, there's no contradiction between the two, the non-locality on the one hand, and the locality on the other hand, and the randomness on the one hand, and the cause-effect efficacy on the other hand. There's no contradiction. If you can explain this, this, what is seen in the macro world, does not hold true in the macro world. Why? If you can explain this, then they say, from Buddhist point of view, we will say that because the things exist only with the reference of mind, and now you are shifting the reference of mind, frame of reference, from the conventional to the ultimate. When you go to the mind analyzing the ultimate, you will not see the conventional. It doesn't mean the convention does not exist. Likewise, when you employ the mind to analyze the convention, it does not reject the ultimate, because this mind does not examine the ultimate at all. There's no contradiction. So this is how you can decide. Physicists, what would be your take when you go to the randomness, non-localized nature of the electrons? Then what would you be take on the macro world, the efficacy of the macro world? This is what I'm saying. The world, efficacy, undeniable macro world, efficaciously existing. How do you explain this?
No, we'll discuss it in other topic where randomness is there, epistemic or ontic randomness. Nicholas has written his whole book. Maybe where we can discuss. We have another topic.
Okay, so we'll come back to this question
Yeah,
later.
we'll come
Okay,
back. Yeah,
very good.
yeah. Now, the another is a little bit different thing, like Gadenkin experiment, the thought experiments. So, in physics and philosophy, and most of the sciences, social science, etc., some thought experiments are proposed. And like in quantum physics, many really outstanding thought experiments like cat paradox, Wigner's trained, a lot of other things. Even in classical physics, there are thought experiments. And similar thought experiments are there in Buddhist philosophy also. So uh, let me ask Nicholas to explain why thought experiments are proposed, and by that, what we can gain in understanding the reality.
Yes. Yeah, thank you, Cecilia. Yes, that's a good question again. Yeah, thought experiments is really what, you have your imagination. That's one of the power that humans have, this imagination. And before really doing an experiment, which is usually difficult, complicated, sometimes even impossible to do, if I make by imagination, I can go to the moon and move a stone, but I cannot really go, at least myself, I cannot go to the moon and I cannot easily move a big stone on the moon. So there are many things where we can do things per imagination, and then I can analyze again with my imagination the consequences. It's not pure imagination. Of course, I have my theory, and I guess, okay, if I do this, it has that kind of effect. And I do these assumptions that indeed my theory possibly describes this thought experiment. And doing this has been extremely valuable in physics since ever. And we see that some of these thought experiments, are then, thought enough that we can, that we should do the experiment. For instance, this non-locality that we were talking about, it was first a thought experiment, was initially proposed by Einstein, Podolsky, and Rosen. So that was a long time ago in 1935. And the first experiments really are on that. Okay, in between there was also a lot of theory with Bell's inequality, but the first experiments were only in the 70s. So, many decades or several decades later. And so, yeah, thought experiments is super useful to prepare a real experiment. At the end, we want to have a real experiment. But sometimes also you cannot do the real experiment. For instance, one thought experiment that already Schrodinger, one of the father of quantum mechanics, proposed was not only to have this, indeterminate properties of an electron, but let's have a cat, and let's have the cat in such an undetermined state that it could be, dead and alive. That's the standard way of talking. But we immediately see that this is not possible in reality, for technological reasons, maybe also just because we wouldn't do that with a real cat. But it's also technologically impossible to do that. But still, it pushes physicists to try now to go to objects which are larger than a cat, larger than an electron, maybe like a crystal, or maybe like a large ensemble of atoms, not just one atom, but many atoms, not as many as in my hand, but still many atoms. And so, well, I think just it means imagination is incredibly valuable in all sciences and in all philosophies.
Oh, thank you. Now, what I can remember in Buddhist philosophy, even after physical death of Gautama Buddha, there was a big debate called Payashi Shukta. Payashi was a prince, and as far as I remember, he came to one disciple of Gautama Buddha, and there was a debate whether vital force exists or like consciousness exists, and he designed the thought experiments what nowadays we design, maybe 1,900 years before or 1,800 years before. So in Buddhist philosophy, it's reach of that kind of thought experiment. So Geshe-la, maybe he can elaborate more on that issue.
Okay. Thank you. So basically, the what we call as thought experiment in physics, and if we are to really draw parallels in Buddhist philosophy, the I would not be doing justice to say that, okay, this thought experiment is then people may understand that, try to say the project the same thing how that is seen in the say what the physics in Buddha. The difference is that, for example, in Buddhism, let's say that for example, the emphasis on what is the effect, not only the identifying what the objective reality is. Say these are all are coming by the pure perception or the projection by the observer mind. It is the projection of that, independent of the observer mind, nothing's there from the object. So this is the one reality. Then the question is, in Buddhism, there's a tremendous, not only Buddhism, in all the, say, the religions, there's a tremendous emphasis on what's the benefit of this? What's the benefit of you understanding this? So that benefit to manufacture, say, some new items. No, it is to bring about the transformation in your thought processes. So now, okay, then they say parallel or similar to what the say thought process exists in, is considered as important in physics. In Buddhist philosophy, I won't really go to extent saying it as a thought process, but for sure, say like very similar to that. Okay, now with this little experience, if I see things like a dream purely projected by my own observer mind, then the what is the consequence to my emotional world, my anger, my agitation? They all come under control. Just as when you wake up from the dream nightmare, when you wake up, that tremendous fear that you had in the dream, which is nothing but the surge of the very corrosive emotion, subsides the moment you come to discover that what is happening was purely coming from your mind, which is the observer. And so it is like correlating the effect on your mind of understanding, realizing the objective reality there. So this is the basic benefit. So with this in mind, since that, for example, let's say today I'm expecting like finally I need to reach a level whereby my mind will not be affected by any external factors of fear, anxiety, stress, and so forth. This is what I'm seeking. Can I achieve that? Yes, you can achieve that, provided you are so well trained to see this, the ontological reality, that ontologically there's nothing there from the object of the emptiness for objectivity is the ontological reality. If you keep practicing this realization, then you will reach to a level whereby you will not be affected by external factors. But for the time being, I don't see that happening within me. So I have to now imagine it, that these, as Professor Nicholas very clearly indicated, it's not pure imagination. It involves theory and so forth. Likewise, in Buddhist philosophy, it involves lots of theories there. So with these theories, then you reach to this level. From this, if you practice further, you reach to the next life, next level, and so forth. So this is what is being explained. And then pertaining to the Schrodinger's cat experiment, this is very interesting. And the way and the manner the Schrodinger explained the superposition of the cat is dead and alive at the same time. So this is interesting. When not observed, what's the state of the cat? When not observed, what's the state of the cat? So that is called the superposition of the cat. So what is that? When not observed, what's the reality out there? So if you could remember how I began my talk, is that, say, in Buddhist philosophy, particularly from the high philosophy point of view, the things, what is this reality? They say there are two things. What are the things? The next is, how do they exist? Do they exist as how they appear to you? Things exist. Do they exist the way they appear to you as objectively real? Then the answer is no. So things exist only by having a mind as a frame of reference. Without the mind as a frame of reference, nothing really exists there as the object. So with this in mind, then if there is no observer, then what is the situation of the cat? What is that? What is that? What in physics is the many scientists call it, the quantum physicists call it the superposition. So in Buddhist philosophy, what do you call this? So if you discard, just theoretically, if you discard all the minds as the frames of reference, then what is the there is what is known as inexpressible reality there. Inexpressibility there. So superposition, which cannot be expressed as dead, which cannot be expressed as living. Likewise, there's the phenomenon known as inexpressibility. That's there. So that, if you discover it, the true nature, if that's what you discover and you practice it, then the emotional transformation will happen, and all your fear, agitation, all these things gradually subside, that you will see that there's nothing really there to be expressed to affect you, your mind. Your mind finally finds the rest. That is known as the nirvana. And the more refined version of that is known as the full awakening or Buddhahood. Thank you.
So, thank you. Nicholas, I am wondering if somebody can design a thought experiment where the mind, or we call consciousness, can be included in measurement problem. I don't know if somebody can.
No, I mean, yeah, it would be really nice if we could do something like that, because it would mean that we could define mind in physical terms. I'm not saying in terms of atoms or like that, but today for the physicist, mind or consciousness are concepts which are so far removed from anything we understand physically that we cannot really include it in a real experiment. Of course, what we can do in a thought experiment is to say, okay, now we put a human being, a Wigner's friend or someone, into our experiment, into our thought experiment. And then we see that we can easily enter all kinds of complicated and sometimes even conflicting conclusions. And I think this is just showing that physicists don't really understand what the mind or what consciousness is. I'm not saying does not exist. I'm just saying it's not yet part of physics. It's not yet part of science.
Thank you.
And Professor Sirji, just one thing to add. I personally would say that the physics, as of now, of the rigor of the physics, if you expand the circle, the horizon of the physics research, like touching the mind and so forth, then I fear that the rigor of the physics has to be compromised. As Professor Gisson very clearly indicated, that yes, the mind exists or not exists, this is a non-physical reality. If it does exist, it is a non-physical reality. And so because of this, physics by the very definition is to do with the physicality. And yet today, what we call as constantly I use the word the observer, the mind is the observer. When I use that, it's not that you have to include the mind in the measurement, but let's say that the way the manner in the say the quantum physicists would say, in the absence of the observer, what's the object? In the absence of observer, what's the object? So there, then the uncertainty principle and the superposition, the concept, all these things come into being. In the absence of observer, then observed makes no sense. So from this, it is almost like going to in fact, I've been listening to the lectures in quantum physicists, but the different scientists, and some of them go to extent of saying that from this point of view, in the absence of the observer, observed makes no sense, which means that almost like rejecting any degree of objectivity. This is what is being said. But in terms of taking the measurements, yes, I would say that is best measurement is to do with the physical. So it's better not to include the mind or the consciousness, to do it keep it very pure as physical. It doesn't mean that it explains everything, but what it explains is going to be very rigorous. That is the beauty of physics.
Okay, thank you. We have many other questions, so let us go to the next one, and which is nowadays it's a very favorite topic of Nicholas. The concept of time and time in Mulamadhaymika Karika by Acharya Nagarjuna. Uh, Professor Nicholas, he has written very thought-provoking paper recently, 4 or 5 papers he published, and he has a new idea regarding time. So let us listen what his idea on time, concept of time.
Okay. Well, thank you. Although your question is a very difficult one. So time is clearly a physical quantity in the sense that we can measure time. We have clocks, no? And we can, many different ways of measuring time. But what is it really ultimately? I guess time is something which is creating new properties. It's making something new. If absolutely nothing happens, now that's again a thought experiment. Let's imagine you are completely isolated and absolutely nothing happens. Then somehow time does no longer pass. Of course, something is going to happen probably in your mind. It's probably difficult to have exactly nothing happening, but at least physically around you, you could imagine that nothing is moving, nothing is getting warmer or colder or so on. No radiation, nothing. So time is a kind of creative power. And how do we physicists describe time? So there is the way of describing it as already in Newton's mechanics. And in Newton mechanics, it's really like a clock. It's something that moves on completely steadily and continuously without any surprise. It just goes on exactly as a clock. A perfect clock should never surprise us. It just, time passes in a totally mechanical way, very regular. The way time is described in quantum physics is already quite different. Actually, we have the Schrodinger equation. So we have also this Newtonian time there. But in addition to that, we have these measurements. When we make a measurement and we force a property to acquire a determined value. And so here we have really something creative because, the electron could be here and there in superposition before the measurement, but after the measurement, it is definitively here or definitively there. So we have created, or we have forced nature to create some determinacy. And this is a completely new way of thinking of time. And then there is even physics has even a third concept of time, which is now connected to relativity, where time is at the same time this kind of clock that just goes on forever without any surprise. But the way this clock advances in time, so the passage of time depends on the reference frame, but not the reference frame of a mind. It's just the speed of the observer, or the speed of the clock, you could even say. And this has even been measured. If you put two clocks at very different speeds, you can see that one is going to tick at a different rate than the other. So this again is something undeniable. But we see we have many different concepts of time. And I don't think there is just one that is correct and the other one which is wrong, but I think it has different aspects. And what is a kind of unifying aspect of these different times, we don't know yet. We, the physicists, we don't really know. So Cecile, you were kind enough to mention that I recently published several papers on that. So the idea for me was to go back to Newtonian mechanics, where we have the feeling that we understand that quite well. We have a lot of intuition about Newtonian mechanics, but let's apply it to a system which is what we call chaotic, something super complicated, like the climate. The climate is something super complicated and super important. But here, because of the complication, the chaotic aspect. If you would change just a little bit the things, we talk usually about this butterfly effect. If there is a butterfly that just moves a few air molecules, that may have a huge impact on even the weather tomorrow and possibly even on the climate. So we need to understand that. And so in these papers, which I don't want, okay, if you want, I can go much further into that, but this is, my recent research. But I think we can here also go into and see time, the passage of time in classical mechanics, we've also some creative time passage. And the way I do that is by saying that we need to also adapt our language, and the physicist language is mathematics. And the usual mathematics that people learn at school, at university, is called classical mathematics. And classical mathematics, all the numbers and all the objects are really existing in a kind of Platonistic world, which is a timeless world. So it's a timeless language. And if you use a timeless language like mathematics, it makes it very difficult to talk about the passage of time. And there exist different sorts of mathematics. Okay, the one which I prefer is called Intuitionistic Mathematics, was invented a century ago and still under development, but it's very precise mathematics. And this in this mathematics, numbers are evolving processes. So they are processes that evolve in time. So it's a mathematical language which has time built in. And with this language, one can really talk about the passage of time, even in Newtonian mechanics, in a way a bit similar as we talk about the passage of time in quantum mechanics, where time passes or time becomes creative when you perform measurements.
Thank you. I just want to remind you one famous statement by Albert Einstein, probably you know it, that before his death, he wrote that difference between past, present, and future is only a stubbornly persistent illusion.
Exactly. Yeah. So indeed, Einstein had a very strict understanding of time. I would also say a very narrow understanding of time. Of course, Einstein was a genius, that's not the question, but his understanding of time was very much that of a big clock. And you have only this clock going on without ever any surprise. So Einstein is also famous for having said that God doesn't play dice. So everything is already determined since ever, forever. And this is in contradiction with quantum mechanics. And Einstein, indeed, so he was consistent. He said, okay, quantum mechanics cannot be the correct theory, because there you have indeed this creative time passing. And I would say that probably Einstein would also not have liked my intuitionistic mathematics as a language describing the passage of time also in classical mechanics. But that's okay. Einstein had his view. I mean, Einstein is the genius who brought relativity. And there are different opinions. I would also say that probably the majority of the physicists are still very much influenced by Einstein and close to Einstein. However, in quantum mechanics, you have more and more people who, with more, it's the more traditional Copenhagen view that you really have randomness in quantum mechanics. And maybe I should also add, randomness doesn't mean that it's just chaos, that it's whatever. There are very precise probability rules. So it's not the lack of rule. It's simply that these rules or this causality, it's not that everything can happen. It's not an elephant that's going to happen here suddenly. There are rules, but these rules are probabilistic. Still very precise, but probabilistic.
Okay, so let me go to Geshe-la. In Arya Nagarjuna's book, Mulamadhaymika Karika, probably chapter 19, he talks about time. And as I understand, he said time is a mental construct and past, present, and future in illusion. So, Geshe-la, can you explain?
Okay. Before, in fact, I'm very keen. Before I go to my explanation, the first, I'm just wondering, Professor Nicholas, if you can, from a very standard point of view of physics, or from your point of view, what how do you understand what is time? How would you explain this?
It's the power of creating new information. So as time passes, new information gets created.
So when in time, the information is created. Information per se, is that the time? This is the question. Then the phenomenon of creation, is that the time? This is the question. What is
Yeah,
time?
Okay. So first of all, the easy answer is I don't know what time is. But let me try to still say that time for me is really the accumulation of little act of creations. Time gets information, gets accumulated, and as information gets new information, fresh information gets created and accumulated. This is really the passage of time.
Okay. Thank you, Professor Gesen. So in this connection, what I'd like to share with you is that the time is being explained in Arya Nagarjuna's text, and also explained in Acharya Dharmakirti's text, and implicitly what the axioms of the Buddha's teaching, and there are the 4 lines. The first line says, all composite things are impermanent. Impermanent means change. Change connotes time. As Professor Nicholas said, the creation of new information. New means change. What was non-existent coming into being, that is a change. So, in other words, the phenomena, as Acharya Dharmakirti explained, that the substrata, the substance, like the atoms, electrons, so forth, of course, that present, yes, they do exist. They do exist. And these substrata of the physical reality plus the mental reality, so these have the intrinsic nature of the undergoing change. No matter what, physical, mind, whatever it is, anything that falls under these 2 categories should necessarily, invariably undergo change moment by moment. So this change means that what was before was not static. It was the new thing that came later. So the gap between the 2, initial stage and what came later, that gap is known as the time. In fact, this was the debate that I had with a physicist in Cambridge, I think about like 14, 15, 16 years ago in Cambridge, where I met with a brilliant physicist, really brilliant. I really appreciate his intelligence. And our common host, he he introduced me to him, and then our common friend, he also told him that this monk, he's interested in physics also. And then he said he was very dismissive, but because that we have a common friend, just to make the common friend happy, he said, "Okay, tell me whatever question that you have from physics." Then I was just very genuinely asking about what exactly is momentum and so forth. And then the concept of the time came, and he said that there's no time. And I said, no, I'm not asking your view. I'm asking the standard physics view. And he said, no, there's no time. Then I said, okay, this is not my intention. But if you want to, you are deliberately provoking about the existence of the time. So then we started to have an actual debate on this. And then I asked him, and asked, so you explain what it's been. If you say there's no time, explain how the time is not there. Then he was trying to, explain things, and finally he was saying that I don't accept it, doesn't exist. Then I said, okay, now it's my turn. Time is two events. They don't exist simultaneously, they exist consecutively. So there's a gap. That gap is the time. Now, this gap makes sense only in relation to a substrata. A substrata, for example, as Professor Kissinger said, that if the world is static, nothing is moving, there's no time. Time makes no sense. Time makes sense only when things are existing. And what are the things that are existing? And the Buddha said, all composite things are impermanent. Impermanent means nothing remains. All this, not nothing. All composite phenomena, things made of physical reality, things made of mental reality, these two things never remain static, even for a single tiniest moment of the time. So that gap between the two events, the first event and the second event, or the first moment and second moment, which invariably exists, there's a time. And then depending on, what frame of reference, let's say the manner in which the relativity theory explains the time dilation concept of the time dilation. So there again is with the frame of reference, not with the mind as the frame of reference, but as the speed, or as the movement, the speed of the object. So that is a frame of reference. Then the time is explained. What is that gap? Short, small. So let's say theoretically or hypothetically or thought experiment. So what is the person on the planet Earth? Planet Earth with its own particular speed, and then on the other hand, somebody in the extremely fast, the aircraft. So how the time, what is the time? These are very different to do two of them. So the point is that is not rejected. So now, Arya Nagarjuna, where Professor Cicero said that the time is illusion. Okay, so we hear this is so important on that time. Arya Nagarjuna, particularly how Arya Nagarjuna is read by many philosophers, is not done very I'll say the healthy way. Say this distinction should be made: illusion and illusion-like. Illusion-like. Time is not illusion, and they say the external world is not illusion. Physical world is not illusion. Physical world is illusion-like. How illusion-like? Just as illusion is what appears to your mind without anything, say, from the objective, nothing is there, but coming from your mind. Likewise, all phenomena, though they exist, but they exist by the power, purely by the power of the mind. So they are not illusion, they are illusion-like. The mode of existence of the things. Things do exist, but the mode of existence, this is being discussed, and the time exists, but the mode of existence of the time is illusion-like. Thank you. Done.
You have, Cicero, you have to turn on your mic.
Yeah. The question now comes about continuity. I mean, Greek philosophers, they introduced two concepts, kairos and chronos. One is duration, another is instance. Buddha also talked about this in a metaphoric form. So if you consider this is duration, then probably people faces difficulty understanding continuity of time. We don't have time now. Maybe we can discuss the next one and then close for discussions. And next issue is very, very interesting also. This is determinism versus randomness, epistemic versus ontic concept. So let Nicholas starts, and because his whole book is, devoted.
Yeah. Okay, thank you. Yeah, it's very interesting discussion, especially about time, because this is such a hot topic for me. Continuity, just let me say a word. I think even defining continuity very precisely is not that clear, because You have the line and you say, okay, this line is continuous, but are the elements of these lines all like little grains of sand that are completely made up already now? Or are the points along that line kind of evolving processes? That's maybe also the basic difference between classical mathematics and intuitionistic mathematics. Okay, but let me come to what you just asked, Cecilia. For sure, there is indeterminacy in quantum mechanics. That's very well accepted, but also I think in classical mechanics, Newtonian mechanics, if you go to this intuitionistic mathematics. Now, is that purely just epistemic, or is it ontological? Epistemic would be kind of banal or not so deeply interesting, because, for instance, I could have forgotten where I put my keys or where I put my bicycle. And so I say, oh, maybe my bicycle is in the garage, but maybe it is behind the house. But actually, for sure, my bicycle is somewhere. I may have forgotten where it is, but for sure it is somewhere. So this is purely epistemic indeterminacy. It's just that I don't know, which is not super interesting, for science or in general. My ignorance is, no one should be too interested in my personal ignorance. But now, according to quantum physics, when we say that there is quantum chance, as my book's title, we really mean that this chance or this randomness is intrinsic to nature, or it's intrinsic to this atom or to this electron. It has nothing to do with my ignorance. Of course, on top of this ontological randomness, there could be also ignorance. Maybe I even ignore it, and that would just add even more indeterminacy. But it's not. Then there's a mixture of ontological, the real indeterminacy of the atom, and then just my ignorance. So let's suppose I can remove all my ignorance about this atom. At least I can never do it in reality, of course, but I can do it in theory. I can do, again, a Gedanken experiment, and I really think, okay, no, I know exactly everything about this atom, everything that there is to know. And even quantum theory says, even if I know exactly everything that there is to know about this atom, or maybe about these two atoms, to come also to non-locality and entanglement, even knowing everything, which physicists use the terminology that, I have a pure state description of my atoms. Even if I have this pure state, this complete description according to the theory, everything that there is, I know. Even then, if I do a measurement, or if I let just time pass, there will be new information created, in the sense that some property that were initially non-determined may get determined. They get determined in a random way, so I cannot force it to go to the left or to the right, but at the end it will be either to the left or to the right. It will have acquired a determined, a fully or more precisely determined position. And so this is then really fundamental or ontological randomness. And this is really bringing a lot of tension between quantum mechanics and relativity, because in relativity, people may think that there is no indeterminacy, which I think is something we could also discuss, but this is maybe more complex. But for sure, in quantum mechanics, there is no doubt that there is that quantum theory really claims that there is ontological indeterminacy.
Yeah, but let me make a small comment. Like even in classical level, in Brownian motion, this is ontic randomness. And like Nelson's mechanics, he developed whole quantum theory based on that kind of concept.
Yes, yes, of course, you're absolutely right. And so let's say every physicist would agree about quantum mechanics. Not everyone would agree about even Brownian motion. Brownian motion is like the chaotic systems I mentioned before, the climate. This is an example, let's say, of Brownian motion. And there, we talk sometimes, some physicists talk about deterministic chaos. And I think deterministic chaos assumes that we use this classical mathematics where the initial condition contains infinite information, and so it contains actually all the future. But if you go, this classical mathematics is a timeless mathematics, it's a timeless language. But if you go to this intuitionistic mathematics, you can indeed describe Brownian motion as really an evolution of an indeterministic system. And you also then in this Brownian motion would have a continuous creation of new information.
Okay, thank you. We have very little time, so Gesela, can you finish it sharply within 5 minutes? Because we have some time for discussions, and we have crossed the time.
Okay. Yes. In fact, there are several questions to Dr. Nicholas G, but I'll skip that part. And first, let me finish with my points. What is epistemic and what is the ontologic? So there, from Buddhist philosophy point of view, that this is a very interesting thing. That say the epistemic has a connotation of something coming from your mind. What is coming from your mind? Again, there are two things: the reality. Say, for example, in the absence of the observer, nothing making sense there, which means what is there is epistemic. Another one is, I don't know. This is another very naive thing. Epistemic is purely, it may be there, it may be there, to the right, to the left, it may be. Okay, this is, just keeping this aside, this is very unwise. And so now what is and in fact, Einstein was more into the ontologic, and the Niels Bohr is more into the epistemic. And what I would say is that from the Arya Nagarjuna's point of view, from the Buddha's point of view, which further was explained by Arya Nagarjuna, epistemic or ontologic. This is a very important point. I'd like to make the statement very quick. The statement is that not seeing anything is saying the ontology. Not seeing anything. Objectively, there's nothing there to be as ontology to be seen there. That is seeing the ontology. Okay. In other words, emptiness of objectivity of the object is the objectivity of the object. This is extremely important point. So where I personally would say that the both concepts of what Einstein was proposing, what Niels Bohr was proposing, so somewhere this is what binds the two in ways that Einstein is more into determinism, that there's something should be there, ontologically something should be there. So here the Buddha in his present the understanding of the reality says that the inexpressible reality is there, inexpressible reality. That is the ontological reality. Okay, and so from that point of view, it is like what the Einstein's presentation of the ontological realities. There should be something there, and then yet not seeing anything. There's nothing to be seen there, which means what we see is just purely projection for your own mind. Projection. So that is epistemic, and say in other words, the purely epistemic, and then the absence, withdrawing the subjectivity, what objectively what is there, there's nothing there. There's inexpressibility there. To be existent, this is known as a very famous tetralemma. The presence is negated, absence is negated, both presence, absence is negated, and then neither absence and the existence is negated. All four are negated. So that is known as the inexpressibility. So that inexpressibility is the ontological reality, or that is what is known as the intrinsicality. The intrinsicality is absence of intrinsicality is the intrinsicality. This is, of course, we can discuss more on this later on. From my side to wind this up, let me ask one question to Professor Nicholas, that is that you talked about the randomness being the intrinsic nature of the electrons, protons, and so forth. And yet the randomness is not seen in the external conventional world. So pertaining to the house, pertaining to the bicycles, keys, and so forth, would you assign randomness or not? So forget about that part. I don't know. Forget about that part. Otherwise, randomness, do you assign it? If you don't assign it, which means that it is confined to the micro world, microcosm.
Yeah. Thank you for the question. So let's move indeed. Let's leave aside ignorance, which is not interesting. But I would say that randomness also exists in our world. For instance, the climate or just the weather. The weather in 1 week time in Geneva, let's say, my place, is not yet fully determined. So I also see this Brownian motion that Cecilia was mentioning before. So also on that level, which is really the level of us, a human size, I believe there is also intrinsic randomness at that level.
Okay, so since there are so many questions coming up, and I won't really interrupt between the audience and the participants here.
We have two questions left in this session. It's not be possible. Let us ask the audience for their questions.
Yes.
Okay. Yeah, any questions from the audience? I don't see. No questions?
Here is one.
Yeah, okay. So this is for Nicholas. Yeah.
If you haven't...
Yeah, this is for you, Nicholas.
Yeah. Let me just read the question first. But I cannot read the end of the question. It ends up with three little dots.
Okay. Thank you, Professor Siroji, for sharing, and our two speakers. Okay, so moving on to our today's question answer session. So we see the first question from John Owen. So he's asking, if you haven't yet gone to measure a particle quality of particle, how did you determine it was totally random, unstructured, etc.? Wouldn't the determination of lack of structure equate to lack of measured structure, thus implying a measurement at the pre-measured time? So he's asking this question to Professor Nicholas.
Yes. Okay, well, thank you very much for the question. It's a good question. It's a very natural question. And the first answer is, of course, just that the theory says, quantum theory says that these particles, at least some property of these particles, are totally undetermined or totally random. But why do we the physicists really believe this? This has then to do with non-locality. If you have this non-locality, and technically we say violation of Bell inequality, so we really can prove this non-locality in real experiments. And we also want to say that there's no instantaneous influence going from one to the other. They are 10 kilometers even more apart. So it cannot be something that goes instantaneously in zero time from one to the other. Maybe it can even go faster than the speed of light, but it does not go instantaneous. And then if you accept this assumption, which is a very natural assumption for a physicist, then you can really prove mathematically that the outcome of the measurements have to be truly random. Whatever measurement you can do, for instance, on these spins, you can measure it in different directions, and whatever direction you measure, you will get a totally random outcome. So this is more than just the theory. We really have theorems, very rigorous theorems. And of course, like every theorem, you need some assumptions. And the main assumption is this idea that a possible direct influence from one to the other cannot be instantaneous.
Thank you, Professor Nicholas. So moving on to our next question. It is from Venerable Lobsang Tonyola. He's asking if there is no genuine relation between atoms in an emergent phenomena, but the imagined coarse-grained object is entirely projected by the mind, how is it right to project hand onto one collection of atoms, but not to another? That is, the particles which compose a foot. Mustn't there be some distinction apart from the projection that allows our collection to do hand actions and another to do foot functions? So this question, I guess, is directed towards Venerable Geshe-la. Professor Nicholas Gisson, you would like to comment on this question?
Well, I think that's more for my friend in Delhi here.
So basically, I would say that, yeah. So this is for the physicists. How would you explain this? For Buddhist philosophy, this is easy. It is your mind plays a role. For example, say the same object can be seen in different ways by the different people. When you are very upset, you look at a flower, you see the flower is very dull. When you're very happy, you look at the flower is so illuminating. This is all of your mind. But how would the physicist would explain it? If it's just a bunch of atoms and you see it as it acts as this a hand, not as a foot. So this is, I think, the question to Professor Kissinger.
Okay, so let me try to answer. Well, I think for a physicist, you have this bunch of this collection of atoms, and they can be in different relations to each other. You know, in this is a collection of atoms, my hat here, and this collection is not just randomly positioned. I mean, these atoms have some relations to each other in such a way that they constitute a hand, and they have the form of the hand and so on. Well, if I if you imagine a foot, it could be even the same kind of atoms, maybe even the same number of atoms, but the relations between these atoms, we are organized in a different way, in such a way that they constitute now a foot, or we constitute a cup, or, you know, can constitute whatever. So indeed, atoms can be, this collection of atoms can make up by the way they are arranged with respect to each other, many sorts of objects.
Thank you, Venerable Geshe-la and Professor Nicholas G, for commenting on the question. So our next question, our IT person is going to screen on the screen. So it is from Professor Ravindra Nagendraji. Professor Sisi Royji, would I request you to read the question so that you can direct the question to either of the speakers as your discretion?
Yeah. Mind, according to Shankha philosophy, is a very subtle matter, within bracket physical. How does Buddhist philosophy distinguishes between mind and consciousness? This is non-physical according to Shankha philosophy. So I think this is for Geshe-la.
Okay, thank you so much. So basically, I would say that what we have is we have the body and the mind, and the mind is purely okay. So one thing which is very interesting for all of us, for the audience, is that when I was in England, it was like 16, 17 years ago when I was in Cambridge with the same the physicist. What he said was that in this world, only physics is education, not others. And I asked why. Then he said that because only physics allows you to have a critical thinking. All others are imitation of the earlier teachers. So to a great extent, I agree with this physicist, because we just follow on the basis of what somebody taught us. Like, oh, the mind is a non-tangible phenomena. Mind is a tangible phenomena. Mind is made of matters. Mind is not made of matters. We just believe in this. This is where we're going wrong. So in this connection, I told this physicist that, okay, hold on, before you say that only physics is education. Then I said, I quoted the Buddha, where the Buddha said, the bhikshus and the wise people, just as the goldsmith tests the purity of the gold by cutting, rubbing, and burning the gold, you should also examine my words and put them into practice, not simply because you respect me. Then this physicist, he remained silent for a few seconds, and he said, oh, the Buddha must have been a great physicist. Okay, so what I'm saying is that this approach is extremely important. We should not just follow blindly because somebody said it. Or Dorji said that mind is not tangible. Samkhya said that mind is tangible, it's a physical. So this is not how we should follow. The point is that we must look for the objectivity. How things, our approach must be very objective. This is the point. So with this in mind, for example, I'm thinking at the moment, I'm thinking of how does the randomness work in quantum mechanics? When I'm thinking of that, the neuroscientists, they can see almost like every cells of my body, neurons. And the physicists, theoretically, let's say, they can identify every atom of my body, my brain, but they cannot see what I'm thinking. And this is an undeniable fact that there's a phenomenon which this phenomenon which is operating, which I'm aware, which the scientists are not aware. That phenomena is known as mind. If it is physical, it should be what others, the scientists, particularly scientists, the neuroscientists, physicists, they should be able to see that. They cannot see that. This is what is beyond what they can see is known as non-tangible. So this is how it should work. And now the distinction between mind and the consciousness, in the first place, this phenomena, which they shared with you, the empirical experience that I am thinking, I'm just wondering how randomness works on the quantum level. When I'm thinking of this, the other people, they're not aware. I'm just close my eyes, I'm thinking about it. So there's this thought process happening, which is undeniably experienced by myself, nobody else. So this phenomena, which undeniably I experience, which is non-tangible, this is a mind. Then this word consciousness, and in the other classical Indian, the traditions, religious traditions or philosophical traditions, they talk about consciousness, referring to the self, which is something very different from the body and the mind. So that self, which is explained as different from the body and mind, is something which is not accepted in Buddhism. So if the consciousness is to refer to such a self different from the body and the mind, then the Buddhism doesn't accept it, whereas a consciousness to be understood as this intangible phenomena, which is a very refined version of the same mind, like the gold which is very impure gold. You keep refining it, and then finally all the impurities are removed, then it has a very different state of glow. If you call that the unrefined gold-like mind as the mind, and the refined one as the consciousness, this is what Buddhist philosophy accepts. Whereas if you accept the mind and consciousness as two distinct entities, the mind exists, the body exists, alongside there is the consciousness which is different from the body and mind exists. This is not what Buddhism accepts. Buddhism accepts only empirical realities, not what is to be seen or experienced. Thank you.
Is there any other question?
We have more questions. So our IT person has again shown the question on the screen.
Yeah.
Can
we explore the measurement problem in quantum physics from the viewpoint of Master Arya Nagarjuna? So I don't know who is going to answer this one.
Yeah, good question. I'm afraid I don't know this master. I should probably, but I don't know. So I cannot really explore the measurement problem from his point of view, because I don't know that point of view, I'm afraid. Sorry.
Okay. What I would say is that so with this, at one time there was a conference, Mind and Life conference, a Mind and Life conference where Professor Anton Zelenka, he also attended, and he was presenting the quantum physics point of view there. And before this conference, His Holiness called me, and His Holiness was asking about, the basic structure of the conference, the subject matters of the conference, and about his own book, which is The Universe in a Single Atom, which talked about the quantum physics, then the relativity theory, and also the neuroscience and so forth. And and then His Holiness asked me, what do you think about quantum physics? And then my response to His Holiness was that the manner in which Professor Gissen said that I don't know the viewpoint of Arya Nagarjuna. So likewise, I told His Holiness that until I go to do the experiment myself, I can't really be sure of what the quantum physicists are saying, because there are so many assumptions involved. So many assumptions also involved with what is observed, experimentally what is observed, plus assumptions involved, and then say that this is correct. So with this, one of the question that hit me was, Einstein was totally against the concept of randomness, and Niels Bohr was totally against predeterminism. And if these two giants are not there, then the most likely the mediocre scientists will say that if they follow Niels Bohr, they will say that the predeterminism is already ruled out by physics. And if somebody follows Einstein, they will say that the randomness is ruled out by physics. So therefore, my question, given that there are two giants there, my question is, even physics cannot really is yet to determine which is correct, because these two views are very strong there, and people are half-half. So with this in mind, in fact, I personally asked many questions to Anton Zelenka about the double slit experiment, and he was very fascinated. He said that, okay, we have to do you ask me more questions. And then I said that this is the residence of His Holiness the Dalai Lama. The security people will kick us out, so we'll get out. And then I invited him to my place, which is nearby His Holiness's residence. And then it was a great time, a great honor for me. He is a very senior physicist, and then I got a chance to ask many questions to him about the double slit experiment. And so what I'm saying is that, to be very honest, it would be good that, for example, like what Professor Sisiriji is doing, and Professor De Gissen, if you can learn about Arya Nagarjuna's philosophy very objectively, and then people like us get to learn more about physics, then we can see, how, whether it is compatible, whether it's not compatible, whether something can be measured by using Arya Nagarjuna's viewpoint, and so forth. So this will come at that point. Thank you.
Another maybe last question. Someone has written, Mr. Prakash, that a wonderful discussion. A question to Professor Gissen. As a physicist, do you find that philosophical thoughts and insights create a thesis for or inform physicist experiments?
Yeah, okay. Thank you very much. At last, this is an easy question. And the answer is yes, definitively. Yes, for sure. I know that some physicists pretend that they don't need philosophy, but actually all the physicists are doing philosophy. Physics is what used to be called natural philosophy. But even today, just to answer what is randomness and these kind of questions, what is time, we had an interesting 2 short discussion about time, for instance. And all these questions are not purely physics. They are also philosophical. And you start, again, we go back to this idea of this Gedanken experiment. You make up also a Gedanken experiment because you start from a certain philosophical perspective. And for sure, philosophy is influencing physics, and physics is influencing philosophy. And these two activities are not really sharply distinguished. There is a clear overlap. I mean, there are also distinctions, but there is an overlap between these two activities.
So, thank you, Professor Nicholas and Gesela, for this wonderful discussion in the weekend. And I don't think we have time to discuss if there is any questions. What is there any other question?
We have more questions. Actually, we are getting an overwhelming questions, Professor. So this could be our last question. So this is on the screen.
The ultimate reality that physics is trying to approach would still be a functional one, wouldn't be, as opposed to the ultimate reality in Prasangika Buddhism.
So who should answer that? I can only talk about the first part of the question. In some sense, yes. I mean, physics is functional in the sense that, we do experiments. I mean, physics is an experimental science. We do experiments. And so in this sense, if we had a physical theory which would not be functional, which would not make any predictions, that would not lead to experiments. But let me maybe add my question to this question. I think that in philosophy, in particular in Buddhist philosophy, you also want to have consequences of your theory. It is not something that is just floating somewhere. This is something that drives your life, that drives your thinking, and has consequences. And so I think also, like in physics, some theory in physics are clearly wrong. You can disprove them. And I believe, but this is really a question now, that in your type of philosophy, you may also encounter some assumptions that are just contrary to what you observe or what you experience, and so you can also disprove some assumptions. So, would you agree on that?
Okay,
Yeah,
I may may share my view is that the physics as we earlier understood it as physical, purely physical. I say there are two things: physical objects and its attributes. There are two. If we try to, for example, let's say the earlier we are talking about, say, the cells, then the molecules, then the atoms. What's the structure of the atom like? So they're actually looking for the object, looking for the substrata, the object, and then the atom was a structure like, whether it is the structure of the solar system, or like what. All these discussions were happening, and then finally it came to one understanding. So if one looks for this only the pure physical object all the time, then naturally how that is understood by Arya Nagarjuna, ultimate reality Prasangika, is going to be very different, because one is a physical thing, and then the attributes in the form of, say, the ultimate reality and so forth. So that's going to be very different. Whereas the physics, they're moving from the Newtonian physics to the quantum mechanics and relativity theory, with the paradigm shift. Then they are not only talking about the object per se, but the attributes like the randomness and so forth. So from that point of view, I think that there's a great possibility in future to talk about, say, okay, if this principle is what is governing these the elementary particles, so does the same principle govern the macro world? If not, then it is empty with respect to the macro world. So, and then this another attribute of the macro world comes into play with respect to the principle which governs the macro world. So, from that point of view, then something can go closer towards the presenting ultimate reality. Okay, thank you.
Okay, thank you. We don't have any time. Thank you so much for these wonderful discussions. And we have still 2 questions left. Maybe in some other occasions, we'll discuss these things. Okay.
Thank you very much. Thank you.
Thank you, Professor Roy, for sharing the session so beautifully. We are fortunate to have the 2 speakers, Professor Gisson and Venerable Geshe-la, for enlightening us in the various topics from the points of view of 2 traditions, quantum physics and Buddhist philosophy of emptiness. Now, I would like to welcome Ms. Tenzin Domala, Program Coordinator, Tibet House, New Delhi, to kindly address the thank you note. Thank you, Tenzin Domala.
Thank you, Ladinla. And I, on behalf of Tibet House Culture Center of His Holiness the Dalai Lama, New Delhi, would like to take this opportunity to thank the chairperson, Professor Cecil Roy, Professor Cecil Roy-ji, for chairing today's session by discussing most of the topics very comprehensively, and our 2 speakers, Professor Nicholas Gisson-ji, from the perspective of quantum physics, and the Venerable Geshe Damdula from the perspectives of Arya Nagarjuna's philosophy of emptiness, for engaging today's dialogue that seeks to bring these 2 streams of inquiry into the nature of reality, and sharing your understanding with each other and to our audience who are actively participating live from Tibet House Facebook and YouTube today. And thank you immensely for enlightening all of us about the several ways of approaching and observing reality from the field of quantum physics and Arya Nagarjuna's philosophy of emptiness. And to all the audience who have been actively participating from Tibet House Facebook Live and YouTube, and raising lots of questions in the comment section and actively participating. And we are very sorry for the inconvenience for not able to take all the questions due to the time limitation. And last but not the least, thank you, Venerable Geshe Damdula, for always guiding us, and under his leadership, the program of this event, important event, came to the great success. And to all the Tibet House staff, Chochotinla, Namgila, Hatunla, Kamala, Ligwenla, Yangzunla, for your unwavering support in this organizing today's event. And thank you, La. Yeah.
Thank you.
Thank you, Tenzin Domala. Thank you, everyone. And I would like to share that to all our participants who are new to Tibet House, please kindly visit our website, www.tibethouse.in. I would repeat, www.tibethouse.in. And if you would like to send us the questions, please feel free to do us on the email office@tibethouse.in. I repeat, office@tibethouse.in. And we would be happy to share these questions with Venerable Geshe-la and Professor Nicholas Gisson-ji to, I hope, to get answers and get back to you all. If you're interested, please do send other questions. And for any further queries, please mail to us. Thank you so much, and please have a good day, good night, and good evening. Have a wonderful day. Thank you so much.
Thank you.